There comes a point where you'll want to share your app with others. While your app is in development, you might want to test in a production-like environment, share progress with a client or manager, or just get early feedback. You may also want to deploy this app in a production environment for general consumption. There are a lot of options available, including free and low-cost options. There are several things to consider when deploying your app. First, do you have the proper dependencies declared? Second, are your static assets optimized? Third, you'll need MongoDB and other services provisioned in your environment. And lastly, understand the performance requirements you'll need. One of the first things we need to consider as we plan deployment is to understand the difference between development mode and production mode. As far as Node.js is concerned, it boils down to one thing, an environment variable. If we look at the bottom of app.js, we'll see this block that checks for the development environment variable. This is the default, so unless you specify otherwise, you'll be in development mode. An easy way to force yourself into production mode is to set the node.env variable to production. If you're using Linux or Mac OS, you can do this with this command, node.env equals production. When we set up our project, we declared some dependencies as dev dependencies. If you've set up your project correctly, your app will work in production without those installed. One way to test is to copy your app to a new folder and use npm install -- production. This will only install the dependencies, not the dev dependencies. Sometimes you'll find that there are things installed that you don't need, which is a minor problem. Other times you'll find that you declared a production dependency as dev, and it won't be installed as needed. Another problem you may run into is that you installed a module, but didn't save it in your package.json. This has happened to me several times. Lastly, it is possible to install packages on your computer globally. That means they are available to every project. I deliberately try to use this as little as possible. You can see what modules are installed this way by using npm ls --g --depth equals 0. One thing you probably don't want to see listed is Express. Express generator is okay though. Your application has static assets such as CSS, JavaScript, fonts, or images. Often these can be optimized to make your site load faster. Multiple CSS files can be combined into one. Multiple JavaScript files can also be combined. Each of these can be minified, and images can be crushed or optimized to make them load faster. In the case of our project, our style sheets are created with a stylus language, and the middleware we use to create a static CSS file in the public style sheets folder. That's good because it means you really don't have to do anything for your site to work in production. However, it's a good idea to go ahead to combine and minify files. A great tool that can do this is Grunt, which has numerous plugins. The Uglify plugin will take care of your needs for both styles and JavaScript. Note that you don't need to minify your server-side JavaScript, only the files that live in the public folder. Deploying MongoDB can be easy, but getting it done the best way takes a lot of care. If you're expecting a lot of traffic to your website initially, then you want the help of an expert for provisioning. Typically, in high-load scenarios, you will have multiple MongoDB servers in a cluster with different parts of the data stored on different disks, with a backup job taking snapshots hourly or more frequently. Since most new applications start out with little traffic and gradually ramp up, you may not need such a complicated scenario. My smaller apps simply have a single server that runs both Node.js and MongoDB. A next good step is to dedicate a single server to MongoDB. But instead I use MongoHQ, though I've evaluated MongoLab as well. These are services that you subscribe to and you connect to their Mongo servers. You pay based on how much data you need to store and how many queries you need to make. It's a great tool to consider if you have a small development team, and both offer free trials. Understanding your performance needs is important, but invariably it takes a little trial and error. There are a few things you'll definitely want to do. Serve static files with a web server, not Node.js. Reduce the number of modules you need, if it makes sense to do so. Consider what pages will be visited most and expend a little effort to ensure they're fast. Investigate tools that measure website performance to see which areas of your site are slow. For example, Selenium can do this, and the protractor library we mentioned in section 5 allows you to control it with JavaScript. Once you've done that, you can start getting more detailed. How much memory does your application use while under load? Can your app or parts of it work well when they're cached? Can you use Redis for sessions? Are some of your Mongo queries very likely to return the same information? If so, consider manually caching the results or using a module such as Mongoose Cache. Is it time to move from a small hosting or shared hosting server to a bigger or dedicated server? Or maybe it's time to spread your app across multiple servers. Speaking of scaling to multiple servers, you should plan for this from the beginning. Ideally, your app will get all of its data from a shared source, such as MongoDB or Redis or an API. If you find yourself looking through the documentation for a way to create a global variable that can be shared or stored across page views, you're in a danger zone. Any data that changes should be stored in a database. There are roughly 3 ways to host your app. There's shared hosting, which is common in the world of PHP. Fewer shared hosting providers support Node.js, though there are some, with Webfaction being one of the most trustworthy. I won't be discussing this during this series because these providers tend to all have slightly different, usually well-documented ways to set the app up. There's also the dedicated server or virtual machine method, similar to what you'd do if you bought a server or hosted your app with Amazon or DigitalOcean. In these cases, you have full control and full responsibility for installing the software, managing the OS, and configuring the services. We'll discuss this in part 3 of this section. Lastly, and probably the easiest way, is to use a specialized PaaS cloud provider that offers support for Node.js. The environment for this type of service is quickly changing, but 2 that have stood the test of time so far are Heroku and Microsoft's Azure. We'll be covering Heroku in the next video. This has been the boring, getting ready to deploy conversation, and I know we've covered a lot of information. The important thing to remember is that most apps fall into 2 categories. Those that are very likely going to be high traffic from the onset, in most cases because they're replacing or supplementing an existing service, and those that are starting out from nothing. If you're going to have a high traffic site, then you'll need to take some time to work through these suggestions and expend some effort load testing your deployment scenario. Fortunately, you probably also have the budget and resources to get that done. If you are starting out with no traffic, you'll want to keep an eye on your site to see how bursts of traffic affect you. Deploying to a PaaS service allows you to scale up your environment with the push of a button. In the next video, we'll actually do a test deployment to a PaaS environment.